Welcome to our video presentation of our paper, Understanding User Acceptance of Electrical Muscle Stimulation in Human-Computer Interaction. Electrical muscle stimulation, or EMS, offers a unique type of feedback. Traditional output methods, such as vibrotactile, visual, or audio, the computer displays information humans can perceive with their senses. In contrast, EMS works entirely different. It does not only provide output the user can perceive, but also allows for direct manipulation of the user's body. That means that the computer can take over control of user's body and move their limbs. This is a very fundamental change that goes beyond the changes in interface technology we have seen before. In recent years, research investigated various application scenarios of EMS in human-computer interaction. This ranges from redirecting users walking by actuating the sartorius muscle, leading to inwards twist of the foot, as you can see here on the left side. Another example is using EMS to communicating emotions to a remote partner. Here, different muscles are actuated to let users perform movements that they would do when feeling a certain emotion. Third, EMS is used to add safety to VR. This works by actuating the biceps. This results in pulling the arm back and thus preventing the user from hitting the wall. However, using EMS also provides challenges. Giving up control over your own body to a computer is nothing people are used to and happy with. Additionally, the movement generated with EMS does not always feel and look natural, and the cables used for actuation are also making you look like a cyborg. All these things lead to the question, what influences the user acceptance of electrical muscle stimulation? First, we had to select 6 application scenarios. We followed the taxonomy of Faltaous and colleagues who differentiated applications between action and perception. For both categories, we picked 3 examples, mainly focusing on the ones with a high citation count and diversity with regards to the application. In the end, we picked for the action manipulation first, the Cruise Control Project by Pfeiffer and colleagues that controls users' walking direction. Second, accelerating human reaction times by Kasahara and others. And as a third example, we used Ebisu and colleagues' work on percussion learning by creating an EMS feedback loop. For the perception manipulation, we used Nijima and Ogawa work on changing the food textures as a first example. As a second one, we used Lopez and Bowdish work on enhancing mobile gaming by using proprioceptive feedback. And last, as a third perception example, we used Lopez and others work on haptic feedback in virtual reality. Besides these applications, we added 2 baseline applications, sports and health. Sports applications are known from various gyms, and in the health domain, EMS is used for rehabilitation. Both are common application scenarios. Next, we looked into how to measure user acceptance. User acceptance has different facets, and there are various questionnaires assessing it. We reviewed these questionnaires and combined constructs most important to EMS. This resulted in this list of constructs and questions we used throughout our work. To answer our overarching research question, we conducted an online survey and follow-up interview. We received 101 responses for the questionnaire from users mainly from Germany, Egypt, and the US. We presented each application scenario, the 6 research-based and sports and health, in randomized order, and asked for each of them the questions measuring the 9 constructs of user acceptance that we identified before. Coming to the results. Overall, users rated the acceptance of the health scenario highest, but also in the other scenarios, users rated each of them differently. This leads to the conclusion that the application scenario influences the user acceptance. Next, we split the data based on the user's previous experience with EMS. Out of the 101 participants, 58 did not use EMS before, and 43 used it at least once. This included medical treatments as well as participating in user studies. Here, our results showed that experienced users rated the application scenarios higher compared to users that did not use EMS before. Now we looked into the different constructs. For example, the social value. Here, we see a similar trend as in the overall rating. Experienced users see higher social value compared to novice users. Looking into the specific questions, we found that the rating particularly differs when being home alone. This leads to the finding that experienced users are in particular favor when using EMS at home. Looking into the anxiety, and in particular, the fear of hurting oneself, we found again that experienced users were less afraid to hurt themselves compared to novice users, whereas the difference for hurting others was comparable for some of the applications. There are many more findings in the paper. Please have a look there for a complete presentation of the results. To further understand the reasons behind our results, we conducted semi-structured interviews. We invited 10 of the participants of the questionnaire, 5 with experience, and 5 novice users. The interviews lasted about 45 minutes on average. We analyzed the data using thematic analysis following Brown and Clark, applying both inductive and deductive theme generation. Overall, we identified 6 themes. In this video presentation, we will focus on only 2 urge to use and external image. The other themes are described in the paper. Urge to use. Here, we uncovered reasons why users want to use EMS application. P8 said that he would use it if it is clever and helps on achieving a specific goal. P4 adds that it would require for him that it enhances the experience in a meaningful way. P6 said that she would find a way to around the challenges if her desire is big enough. And P10 mentioned that particularly if other technologies cannot bring that benefit, he would use EMS. So in summary, we found that users need to see a clear benefit of using the system and are then willing to do so. For the external image, participants stressed that it should be not apparent. On the one hand, they mentioned the device itself and that it needs to be integrated into clothing. On the other hand, they argued that the resulting movement should also look normal. It should not look like movement of a robot, as P10 argued. However, there are exceptions, such as if the device is clearly recognizable as medical, it would be okay, as P8 pointed it out. Coming to the conclusion, first, we found significant differences between experienced and non-experienced users in our data. This indicates that the entry hurdle is one of the biggest challenges we need to overcome in order to make EMS accepted by potential users. Second, the scenario in which EMS is applied highly influences the user's acceptance. Here, we need to make sure that the scenario is well chosen and provides a benefit to the users. Last, the design of EMS experiences should include consideration of aspects that affect the user's comfort, trust, and appearance. All these factors were mentioned by the participants and seem to influence their acceptance. And with that, I would like to end my video presentation of our paper, Understanding User Acceptance of Electrical Muscle Stimulation in Human-Computer Interaction. Thank you very much for your attention.